Welcome to video clip 4.4 in which we discuss racing events. So to recap boundary events from week 2 or from earlier this week when we discussed boundary events of subprocesses. A boundary interrupting event can cancel a subprocess if it is observed, if it occurs while the subprocess executes. So in this case we have a race condition between two events that both can occur, and depending on which one occurs, the process behaves differently. And in particular in this example that we see here, we have the race condition between the boundary timer event and the subprocess termination. So let's expand or extend this process a little bit more with maybe here's an activity, then we send the invoice, receive the payment, and then we have maybe an archive activity afterwards. So once the subprocess is started, then the timer event is, the timer is started. So, and that maybe after whatever 7 days or we need to cancel the order. Maybe that is what happens here in this scenario. And then we have two events that race against each other. And which are the two events? Well, that's one event and that's the other event. So if the timer event wins, then the cancel order activity occurs. If the end event wins, then the process terminates normally. And this is a typical example of a race condition. So there are two events that can happen in the same interval. The one that happens first wins and decides on the process flow afterwards. And this example or this video clip will show that there are further types of race conditions between events and process models, and also a dedicated gateway for handling this. And that is the event-based gateway. So bpm-n provides a particular gateway which is used to select from a number of racing events the first one that occurs. That's a very useful gateway. And that's the event-based gateway. And you see an example of the usage in the lower part. It can only be used as a split gateway, so the other gateways can be used both as split and join gateway. So the event-based gateway is only a split gateway. So the syntax forbids it to be used as a join gateway. But the different branches that are split out by this event-based gateway can be safely be joined together by an exclusive join, by an XOR join gateway, because the event-based gateway has an exclusive semantics, exclusive split semantics. So what happens in this example? So that's the exclusive gateway. You see the marker. That's the event-based gateway. You see the marker here. And here we have an example where we request offers from suppliers 1 and 2, and then we wait for the first offer to arrive. So there's a message from supplier 1 received. There's this intermediate message event and this intermediate message event. So we wait for either for a message from supplier 1 received or a message from supplier 2 received. So which are the two racing events? Well, of course, these two events are racing. These are the racing events. So whichever occurs first decides on the process flow. So if I receive the message from supplier 1 first, I will choose offer from supplier 1. In the other case, I choose offer from supplier 2, and I can safely merge the two with the exclusive OR join again. All right, so that's how the event-based gateway works. Here we need to have intermediate message or receive events, intermediate receive events, and we could also use receive tasks. The event-based gateway must be followed by intermediate events or receive tasks. When firing, the gateway enables all events on its outgoing edges. So not only message events, receive events, but also timer events, of course, can occur there. So that's also, of course, possible. When firing, the gateway enables all events on its outgoing edges. So once it fires, it's a precise semantics. Once the event-based gateway fires. It enables it listens to all events on its outgoing edges. Upon the occurrence of either event, the others are disabled. So once I receive that message, that one is no longer enabled. Even if I receive it later, I don't care. So I just don't care for that because I selected it. And this also represents an exclusive OR split. But the exclusive OR split is not decided by data, as in the XOR split, in the data-based XOR split, but the decision is taken by the environment. The decision is done actually by the environment. Whoever sends a message first, in that example, selects on which branch to take. So the selection is not done by the process itself, but the process reacts to events that come from the environment. And that's the important difference between the data-based XOR split and the event-based XOR split. I'll have this illustrated a bit further here on this slide. So the normal XOR, or the data-based XOR split, decides on the process, on how to continue the process on the basis of data. Right, so we have here, I decide on the claim coverage, and then the process takes an active decision either to accept or to reject the claim. The event-based gateway, the decision is taken by the environment depending on which event occurs first. This event occurs first, or that event occurs first. So that's a basic but fundamental difference between these two types of splits. Also, there is a remark or a guideline also to event-based gateways, and there might be situations where none of the events would occur, and that is, of course, the process would get stuck. To avoid the process getting stuck, a timer event should be used. So if the environment does not react accordingly, then the process might get stuck. If none of the suppliers sent a message, then I would wait, according to the process, I would wait forever, but of course I will run into a timeout. So after 3 days, I will take a look at the process again, cancel the order, or ask other suppliers or something like that. So it's a good idea to also always use one intermediate timer event here. So that's intermediate timer event. So I wait for the answer of either supplier 1 or supplier 2. If this answer is not happened in 3 days, I will simply cancel the whole thing. Cancel the order in that case. Here we have, so how many racing events do we have here? Well, we have 3 racing events. That is, these 3 events that are enabled after the event-based gateway is triggered. And when the event-based gateway is triggered, the stopwatch is fired or started. The stopwatch is started, and it runs. Day 1, day 2. Oh, I received a message. Wonderful. In another case, it started day 1, day 2, still no message. Day 3, I will cancel the order. So these 3 events are the racing events in this case. That brings us to an end of the short video clip 4.4, in which we discussed the racing events. We took a look at boundary events, and we investigated the event-based gateway, where we can specify race conditions between multiple events, and we discussed also the important difference between the event-based gateway, where the decision is taken by the environment, and the XOR gateway, where the decision is taken by the process itself using data.